Alright, today we're going to talk about FBDs and the Newton's second law. So the first thing you need to know, anytime you get one of these problems, you need to draw an FBD, and this stands for free body diagram. And an FBD will diagram the forces acting on your object. So let's just say that you're standing on the ground. Well, if you're standing on the ground, you have two forces, the force of gravity and the normal force. We can literally add tons of other forces here. So, just for the sake of argument, let's say that we have, I don't know, a force of thrust or that we're applying, somebody's pulling it, something's happening, there's a force that way, and then there's a force of friction this way. Alright, what this allows us to do is to see where all of our forces are acting. And you should always do this on any problem. This way, you can figure out where the forces are. You can figure out which forces cancel a lot easier if you do this as well. So what you should see is if this thing's not moving up or down, that the force of gravity and the normal force would cancel out. And if the acceleration was 0 on this thing, then all of these forces should cancel out. And it would let you see that if you didn't know, say, what the friction force was, if you knew what the force here was, you could figure out that they should be the same. So anyway, if you do the FBD, that should help you out tremendously. Alright, so after we draw the FBD, the next step is to do the Newton's second law. And Newton's second law is, quite simply, the formula, the sum of the forces or the net force. Alright, they're the same thing, but the sum of the forces equals mass times acceleration. Alright, in general, you're only going to worry about not in general. For the time being, you're only going to worry about forces in one direction. So you can either sum up the forces in the x or in the y, not both at this point. Alright? So you should never have like the force of gravity interacting with the frictional force. Alright? At this point in time, anyway. Alright? You can have it happen later, but for right now, that should not happen. Alright? So if you've done that, you've probably done something wrong. That might need to check that out. And when we sum up the forces, you can do two things here. We're all pretty good about this, mass times acceleration. So if whatever the mass is times whatever the acceleration is. A lot of times we forget what this is. In the sum of the forces, you're just going to add up the forces acting on here. So let's add up the forces in the x direction. I would have force minus friction. Now, why is friction negative? Well, because over here, friction is going to the left. And so we generally follow this rule that if it's going up, it's positive, down, it's negative. Right, it's positive, left, it's negative. So anything going to the left, you'll plug in as negative. Anything going to the right, you'll plug in as positive. Okay? It should be noted that these numbers don't have to be stated in the problem as positive or negative. If it's in general, if it's resisting the movement, you should know instinctively that that's a negative number. But more generally, you can just follow that rule of to the left negative, to the right positive, up positive, down negative. Okay, and that should help you figure out how to do this. So let me just give you an example of how this formula may look. Whenever we draw it, we might get a free body diagram that looks something like this, where we have force of gravity, and I'm just going to call it 100 newtons. We might have the normal force, which is equal to 50 newtons. Okay, notice that I didn't call either one of these positive or negative. But if I say the mass of this object is 10 kilograms, which, by the way, you should be able to find using that number. If you don't know how, refer to my force of gravity video. And so what you should be able to do is plug this in to find the acceleration. And so we should be able to do sum of the forces equals mass times acceleration, and that should be 50 minus 100. Now why is it minus 100? Because 100 is going down. Equals 10 times A. And what we should get is negative 50 equals 10A divided by 10, and we get negative 5 meters per second squared. Now, That's good because that means the object's going down, which it is, obviously, if you've got 100 newtons going down but only 50 newtons going up. Uh, and so this works out well. All right? This is how you do free body diagrams and Newton's second law in one go. All right? Good luck.